Hello and welcome to this tutorial on setting up user input to control a robotic arm using C# in Unity 2018-4. Now I'm going to put a download link to a Unity package file for this entire project down in the video description, so check there if you just want a shortcut to that. So to get started, I'm going to first jump into the 3D application that I'm using, which is 3D Studio Max. Now, it's important to note that these principles apply in any 3D authoring software, so these same techniques are functional in Maya, Blender, Houdini, and any other content software like that. I've made the choice to do a bit of setup in the 3D software versus doing some of these steps in the Unity editor. And one of the reasons or advantages of working this way is taking into consideration that any changes that need to be done to the 3D mesh that might alter its structure or hierarchy. So you'll find people who set up rotational nodes and hierarchies inside of Unity, but when they add new parts to their model that are nested or childed in, sometimes Unity wigs out on updating that model, especially when scripts have been applied to it, it's been made into a prefab. So one good example of using this workflow is setting up these pivots and parenting in the 3D application versus doing so in Unity editors. So here we're able to see some of the hierarchy setup that I've done, where I've adjusted rotational pivots and I've labeled those as well. We'll see that everything that's childed of this base rotates alongside with the base. Everything that's child of this arm rotates with that arm, because they are in 3D Studio Max. It is called linking. I wish it would show in the Scene Explorer here where these are underneath or child of all of this, but they don't, but they are linked. So if I break it, then it removes that parenting thing. The other decision I went ahead and did was proper labeling. So when my code is going to rotate certain parts of this model in Unity, I want to know very quickly what those parts are that I'm going to rotate or need reference to, and so I've appended the word pivot on the end of all parts that would end up having to pivot via code in Unity. And this is just my personal approach, but you can use any approach that makes logical sense to you. You could use a P or something like that, or a star. So I went ahead and I exported this out of 3D Studio Max. You could be using Maya or Blender or something like that. And I export this FBX into 3D Studio Max. And again, this project with the completed script and everything will be in the video description. But as you can see in here, nothing special going on. Just an HDRI in the background here that I've provided, which is just giving these reflections and lighting. There's a reflection probe in here too. So it's just giving the model kind of this nice looking sheen and reflection to it, but nothing fancier than that. So I brought this model, like I said, into Unity 2018-4, an LTS version, a long-term support, because of the stability and bug fixes that happen in these versions. I'm also using the tall layout. I prefer to use that layout. By default, it'll come in like this. Usually I will collapse that down to a one column and just scoot it to the side like this. And then I will also bring up my general console and just bring this console down here really small. And then I can easily switch between game and camera and scene view here very quickly. Now this provided mesh, this FBX, and the code that we're going to write will work fine in any version of the editor, even up until the 2020 series. So I want to dive back in and make sure that all of my parent-child relationships are maintained from 3D Studio Max, and that all of my pivot points are in the correct locations. So I need to go up here into the menu bar and ensure that tool handle position is set to pivot and not center, and that the tool handle rotation is set to local and not global. We want to ensure that we're rotating around those pivots that we took the time to manually create and set up in our model, and that we rotate around those local pivots and not around a global position in the world. So as you can see, we are absolutely rotating around those proper pivots, and the child relationships and parent relationships are working perfectly. Those were all maintained. So looking back over here in our project window, you see that I've created my own little folder structure just so that when you import this Unity package file, it comes in clean with this one folder. But in here, just create your own. If you're doing this on your own to follow along, create a folder and call it scripts. Okay, and this is where we're going to save the script for controlling this robotic arm. And we're going to right click on top of this folder and go create C# script. And when we're prompted to create the file name, we can just call it something like arm controller. And I put an underscore in there just to delineate that space. So this created a new C# class that we're going to attach to an object in our scene. And once we attach it to this object, it's going to be a component of that game object. So let's go up into the hierarchy here and hover our mouse in this empty space and just go to create empty here and create an empty game object. Let's name this game object the same thing as our script, arm controller. I do that as a sanity check to know that, hey, this item gets this script attached to it. I know you can't do that in all scenarios, but for things like managers or singletons, that can work pretty decently. And so with this object selected, let's move over into the inspector here and look at this little, hover this little small gear icon here and just click reset because we've got a lot of nasty transformation data here. It's not centered on the world. Let's just reset the thing, and now it's centered in the world and everything is copacetic with that. So now we want to attach the ARM controller C# script that we created onto this game object that resides in our scene. That way it becomes a component of it, and it ensures that the code that we're going to write in this script is going to be executed when this scene is run. So we're going to select this ARM controller here, and we can just drag and drop the script on top of it. You can also click this add component, and in the search bar up here just type the name of the script we want to attach, and it's attached. So now we'll see it's applied as a component to this game object. So whenever we go to the ARM controller game object, we'll see the C# class ARM controller as a component onto it. So one more thing that we're going to want to do here before we get to coding is create two sliders that are going to control the movement of this robotic arm. So let's navigate over here to our hierarchy tab and right mouse click in the empty space and scroll down to UI and hover over slider, and we will create this slider. Now what creating the slider has done is it's created this event system, which just allows us to use event triggers and actually allows us to do cool things with input and menus, moving through menus and things like that. And it's also created this UI canvas. If I select it and then hit the F key, we will go out to the UI canvas and we will look at it in its massive UI space. You'll notice that when we look at a robotic arm, it's super tiny. We have to hit the F key to go down to it. They're just in a different space of scale. So there is our canvas, which represents our game window screen, which is great. This white outline of the canvas does. So some of the things we want to do with this canvas, first and foremost, is we want to look at this canvas scaler where it says constant pixel size. We want to scale with screen size. What this does is just ensures that as the screen's if this were a free-floating window and I undocked this and we scaled the screen up and down, it would allow these sliders to kind of stay anchored to a certain part of that screen. So it would allow for different aspect ratios of devices and screens, and it's super helpful. So let's navigate to this slider here, and we'll just call this slider the base slider. Okay, this is the slider we're going to use when we move the value back and forth on it. It's going to control the platform base of the robot or the robotic arm. Let's hit Control D and create a duplicate of that slider, and we will name it arm slider. Okay, we've already adjusted the scaling of our canvas side, so we should be able to go ahead and anchor these. So if we shift select both of them or hold down control select both, go over here into the inspector and highlight over this coordinate for the anchors here, and instead of middle center, let's do top left. And nothing's changed because it automatically added offsets. Let's zero those out. For X, and for position Y. So now this is anchored or snapped to the upper left-hand part of our screen. What we really want to do here is bring them over on X so that they appear on our screen. If we look at our game window here in the game view, we'll see we don't see our sliders, and that's no good. So let's go and bring those over and say about 150. Go back to our game view. Maybe that's a little too far over. 130, and I can see they're far enough over. Let's bring them down a bit. Let's go 45, and there we go. Now we have another problem, which is they're both on top of each other, so we need to grab the arm slider here and just bring it down a little. We can say 90 is good to go, and now we have a clear delineation here that this is our one slider for a different part, and this is another slider for a different part of our robot. I'm not going to bother labeling them now because this is just for demonstration purposes, but we have a slider that will control input for the base of our arm and then our robot, and then we have another slider down below that will control rotation of an arm on that robot. Okay, and they're appearing very nice in our game view window screen. So I think everything looks good in the Unity editor now, and we can get ready to open up Visual Studio and work through writing up this simple script to control the robotic arm. So if we review what we've done so far, we've created this C# class and applied that to a game as a component to a game object residing in the current scene. So here it is. We've created this canvas UI element that contains two slider elements as children of this, and we're going to use those to control the robotic arm. Let's make sure to save the scene as we have it. So I'm just going to hit save as it is. You are going to want to go File, Save As, and I generally create a folder called Scenes and put it in there, and that's very helpful. And I may or may not have mentioned it earlier, but you usually want to hit Save Project as well. That saves out, makes sure all the changes to the latest meta files or the metadata for each one of these elements in here is also saved out with the project as well. Just in the event that you have a power outage or Unity crashes or computer crashes for some reason, and that way, you know, all of that information about prefabs and changes to scripts is preserved. So every time I save my scene, I also save my project. It's just a little Unity tip. So I've created my own unique folder structure here and naming pattern, but you're free to use whatever on earth you are comfortable with, okay? You're not stuck with this. So let's navigate to where we've saved this script in this project window here, which is right here, and we're going to double click this C# class to open it up in our editor of choice, okay? And so my editor of choice here is Visual Studio 2019. And double clicking should automatically open up the IDE that you want to use for code editing. If it doesn't, you can go into Edit, Preferences, and under External Tools here, you will see External Script Editor, and mine is set. You can go and browse, and you can use Visual Studio Code or maybe MonoDevelop, I don't know. You can also just manually open it up in Explorer and edit it in Notepad, but you lose all of the cool code hinting and code completion, so I wouldn't recommend that. But anyway, so I'm using Visual Studio Community 2019, and one of the first things I like to do with this is remove these comments, and I will I removed something I shouldn't have. Yes, I like to remove these comments that Unity puts in as a template, and I'll keep the start and update because generally I end up using those. So the way I'm going to do this is this is actually a pretty small script. It's pretty short. But I don't want to spend all this time sitting here typing out the code because it's not a rudimentary beginner code tutorial. It's more intermediate, but I will explain what each line does, and what I'm going to do is just kind of bring them over. So because I wrote them in another script file here, and I'm just going to bring them over. So what we want to do up here underneath our class declaration here is create two slots. I call them slots because when we look in Unity's inspector here, when we create a public variable here, it does create a spot for them to drag and drop things in for certain items like game objects and transforms. So we're creating two slots for sliders, the two sliders we created, because we want the code to grab reference to those sliders and take values off of them and move our our robotic arm with them. However, we get a warning that the namespace slider couldn't be found. That's because we don't have the namespace or include up here at the top. So we need to type using, and we will type Unity engine dot and then UI and finish it off with a semicolon. And now we are including that UI library or framework into this class and code base. We can hit Control S or Command S on Apple and save. And this way we have access to all of Unity's UI elements. Okay, so those are our two sliders that we want reference. I'm going to save and we go back to Unity and we'll see that those two empty slots have appeared. So if we go down in our robotic arm here, I'm going to go back and zoom in on the actual arm itself and confirm I have the right pieces. So when we want the base, I did name this base and pivot. So now I know that this is the element we pivot off of. Hold on. Oh, I'm sorry. Back up. These are not the transform elements. These are the slider elements in the canvas. I'm really sorry about that. Got ahead of myself here. So it says base slider goes into the base slider slot, and arm slider. These are the two slider objects that we're going to use to rotate that robot. Okay. So what we need is to track the two values that come off of those two sliders. So what I'm doing is, and that is incorrect, 1 to 1, 1 to 10. So these two sliders have a value that goes from -1 to 1. Okay, and these are their base, these are the starting base values. They will start out at 0, and we just want to track those. So I'm going to hit save, and I did. Oh, no, I didn't. Control S. I'm going to go back into Unity, and we'll see it populate with those. Now they're public so that we can just look at them, but we don't want to set these values manually in the inspector like this. So we would type private in front of them generally, and that does a couple things. It hides them in the inspector, and for our purposes that's the most important part. But it also does something called encapsulation, which keeps this part of the code only accessible or usable inside of this class here and not outside of it, which is really good in a lot of ways, so that you can't kind of stomp over changes in another piece of code. So we have a value for the base of the robot arm, and then for the upper arm we're just going to rotate those two parts. Okay, and then those two parts that we do want to rotate, we need access to those too, and they are transforms. As you can see, I just pasted in public transform robot base and public transform upper arm. This is going to create those two slots for a transform component and allow us to drag and drop those two parts in we want to rotate. And we made them public because we want to see them. Okay, I'm going to save and then go back to Unity, and we'll see those two slots. Here it is, robot base and upper arm. Now every game object in a scene in Unity has this transform component, and that's exactly what it is we want to reference. It just tells us where in location in the world it is, how much it's rotated, and how much it's scaled. Okay, so those two things we created, the base and the upper arm, we want to go grab them. So here's the base. I did append pivot on the back, so we know that that's a rotatable part. Now I don't want to rotate the lower arm, I do want to rotate the upper arm. So I'm going to go back to arm controller. I'm going to drag upper arm pivot in. So now I have the upper arm and then the base. Those are the two parts. We're going to rotate like this. And then I'm going to just, for demonstration purposes, we're going to rotate the upper arm like that. And we have reference to both of those parts now in our code. Okay. Let's just copy in the last bit of the variables. Oh, and here we go. Okay, so what we just copied in, and I commented on here, it allows us to have numbers to adjust in the inspector the speed of each of these parts' rotations. And this is accurate. These are the turn rates for the base bottom part, the arm. We start with a value of 1, but we can go anywhere we want from there. We have a base Y rotation. This is just a basic, this is where this rotation starts at 0. It just starts zeroed out. We have a Y rot min, which is the minimum Y rotation for the base. We say, well, we can rotate negative 45 degrees around Y, and that's as far as we can go. and then a rotation max. So we can go 45 degrees clockwise or positive, and that's as far as we can go. And this is to limit the rotations. And then we do the same thing by limiting the rotations on the upper arm as well, right? And so we start out at a default value of 0, and we say that the upper arm can only rotate negative 45 degrees and up to 45 degrees. Now come back to this code and you can copy it and adjust it, but let me save and show you. Okay, so we populated these things in the inspector now. So the turn rate, just how fast each of these parts is going to turn. So we could set it really fast at 2 or just leave it at 1. These are clamps, so it will clamp the rotation negative 45 and 45. And to explain what that means is, let's go to the base pivot. And we see that the Y rotation of it is 0. Now, you can see that number moving, and right there is about 45 degrees. So that's as far as it'll rotate that way. And then we go negative 45, and that's as far as it'll rotate that way. Now, those are arbitrary values I've decided, but you can customize those to go as far as you want, 90 and 90. Now, on the base, it doesn't really matter because this thing could freely rotate 360 degrees and not do any harm. However, when you have other parts like the upper arm, you definitely want to limit, because it's not physically possible for this thing to rotate any further than, say, 65 degrees this way. And then, you know, it's a machine, so it's not a bone in a human body. It could technically rotate back 230 degrees as well. So this is a part that you can see that these limit of rotations are much more important. Okay, so that's exactly what these are doing. This is clamping the rotation of the base. This is clamping the rotation of the upper arm. This is controlling the speed at which all of it rotates. So in start, this is when the scene starts. It is a inbuilt Unity function like update. This is called when you hit the play button and the scene starts up and this script is loaded up. So I'm going to paste in some code here. And what this code does is it sets some values by default when the scene starts for the two sliders. These two canvas sliders that we created that we're gonna, these two right here that we're gonna move back and forth. Let's take a look at those and I'll explain why we're creating base values for them. So you'll see they start at 0 and they go to 1, and they're 0 to 1. And that is basically by default, that's as far as they go. But that is fully customizable, just not out of the box by default in the Unity editor. So in code, I can take the base and arm slider and create these minimum and maximum values. So I can say that the base slider can go all the way to -1 and all the way to +1. I could make that 10 and 10 as well, depending on how much detail we need in that. So when I hit start now, because I've set those negative values, watch what this does. So the default value will now be 0 in the center, and I can go negative and I can go positive. So we get a different set of functionality, and you can see it kind of updating here in the UI as well. So that was the reasoning behind setting these values by script. Okay. So down in the update function, we want to check for the input. Basically, we don't have any keyboard input or mouse input, but we do have input from these sliders where the user's dragging their mouse across them. So let's create a function called check input, and I'm going to just I'm going to bring it over, copy it in. There it is, and we're calling it an update. So update is a Unity inbuilt function. It is very similar to main in Java or something like that, and it's called every frame of your game. So if your game's running at 30 frames a second or 60 frames a second, this code here is called 60 or 30 frames per second. So it's really good to do things like check for key presses between seconds, or rotate or move objects, make characters walk as seconds progress into minutes and just over time. So we're checking input, we're calling it every frame of your game, and we're saying that that base slider value we created earlier in the code up here, this to store the value of the slider, we're just saying that for the base and for the upper arm that it is equal to the value coming off of those sliders. And you'll see that if you look here, there's actually a value property here. That's what we're grabbing off of those sliders, this value property, and we're bringing it over into our script, and we are setting this variable to it, this float variable. So that's what we're doing. That's the input we're checking. So if we go in here and we hit play, we'll look at our base slider value and our upper arm slider value, and we'll see if we doesn't work. And that's because I didn't hit Control S and save. Always save, always save. So I'm gonna hit play. We'll go back. And then now we see it updating. If you look over here in the inspector, we'll see as it goes negative, it's fully negative, it goes positive, and they're independent of each other. So we can rotate these parts independently. Okay, so that's really great. And that's set. Okay, so this script is almost over. I know I've went on a little while here now talking about this, but it's just about over. So in update now, let's create another function or call another function, and let's just call it process movement. I don't know what to call it. It's arbitrary. You can name it whatever works for you. So we're calling a function, but the function doesn't exist in here. The method doesn't exist in here. So it's red and it says, oh, it doesn't exist in this context. So it's not in here, right? So let's create it, and it would be named the same exact thing as what we're calling it. It's a void, so it's not returning any type. It's just a void function. And inside of this, I'm going to copy in the code that's actually going to do the rotation, hold on, for our robot parts. So this is for the base of the robot, that bottom platform. And we're going to take that base Y rotation value that we have up here. It's just a float that value, which is just a number. We store at 0. And we're going to say, hey, add on to that, make that equal to or add to it the slider value. So as we're turning that slider back and forth, add that to that value, and then multiply it times the turn rate, which is it's just another base turn rate was just another arbitrary float value that we set to 1, which is the speed that it's going to turn. And what it did is it creates this turn rate in here that we can adjust the speed. Basically, it creates a public spot here where we can go and tweak that and make the speed faster. Okay, so that's all that's doing, is just setting this. And then we're saying, all right, so that number could go all over the place, but we want to make it a sane number and clamp that between a couple values. So we say, let's take this base Y rotation that we've created and that we're kind of creating based off the value of the slider and that turn rate. Let's clamp it with this mathf clamp. And mathf clamp just takes a value, a single value, and it clamps it between two other values. So it would take it's kind of like that guessing game. I'm guessing of a number between 1 and 5. And so your clamp would be 1 at the bottom end and then 5 at the top end. And then your base Y rotation is some number in between there. But that number that's in between there can never go lower than 1 or higher than 5. So what we're doing is we're saying, let's clamp that base Y rotation. Let's clamp it by that base Y rot min and base Y rot max. And those are the two that we set up here, the min and the max. These are basically the degrees of rotation around Y that we'd allow at the minimum, at the maximum. So this is exactly where that clamping that's going to stop our robotic arm from turning too far on itself. This is that line that's actually doing that. And then once we've clamped it and set the value based on the slider input and then clamped it, let's actually rotate it. Let's take robot base, and robot base is that transform, which is this, basically this transform right here. Let's take that and actually rotate that object, right? And so we go robot base dot local Euler angles. Local Euler angles are X, Y, and Z rotational. That's why you have it as a vector 3. So when you look at it, it's a vector 3, X, Y, and Z. There is a rotation around Y, a rotation around Z, and a rotation around X. Local Euler angles are, they're different than quaternions. It gets a little complicated, but just think of them as a rotation around that axis. And local means that they rotate, this object will rotate locally around its own pivot and axis versus rotating around kind of the world, the bigger whole world. So it rotates around its own awareness of its own, like, I don't know how to word that, its own angles, rather than the world. I'll find another demonstration, a way to demonstrate the difference between local and world like that, but that's why it's doing, we're using local Euler angles. And so that is all of the rotation we need to do for the base. So now we need to do the arm. And this is almost an exact duplicate of the code above, except it's taking the upper arm X rotation by the upper arm turn rate, upper arm slider value. It's all the same thing, clamping it, and then taking that upper arm transform object right here, and then rotating its local Euler angles by this. Okay, and when we look at this, these rotations, we'll notice for the base up here, we're not doing anything here. We're just using the default local Euler angle Z and Y, but on the Y axis here, because this is X, this is Y, this is Z, we want to rotate the space around the Y, which is basically, it's this. The Y axis is up, little green axis right here. And that's why we're feeding it that slider value as well, multiplied by the turn rate and all of that. That's why you're feeding it into the Y. We look at the upper arm down here, we're feeding it into the X, because here's X, here's Y, here's Z. So we want to rotate the X Euler angle. Okay, and then last but not least, I'm going to paste in another function, because that's pretty much all we need right there. This will process the movement of the robot, check the input. Now we just need a way to kind of reset things, reset our sliders back to a default state as we drag them around. And so we create this function here, this method that is public, because we want to access this outside of this script. If we just did void like this, I'm pretty certain by default it's private, so only accessible within this code. But we want it to be public and accessible outside, because we're going to use an event trigger in Unity to call this function, okay? And all this does is it takes those slider values and the actual position of that physical UI slider in the canvas and zeros all of it back out. And it says right here, resets the sliders back to 0 when you lift up on the mouse click, creates a snapping effect. And this code is done. Control S, and it's going to come back and compile, and we're going to go back to our arm controller, and I'm just going to make sure that the base slider's in, the arm slider is plugged in, the base we want to rotate is in, yep, and then the upper arm pivot is in that we want to rotate around X, yep, that's right, everything is good to go. And then we're not going to be able to call this reset sliders from inside the script. We could, but we're not going to. We're going to use event triggers. So we're going to take this base slider and arm slider and select both of them. And we're going to add a component, and it's going to be called an event trigger. There it is. And I don't like this, but it says multi-object editing is not supported, so we got to do them one at a time. Let's add a new event type. And we're going to say when the pointer comes up. So think of the pointer as the finger or the mouse on the slider. So as I have the mouse down on the slider and I'm holding down on it and dragging back and forth, it's down, pointer down. When I let go and stop sliding, it's going to be pointer up. So we have created a pointer up base event. And then we're going to hit the plus button, and it's going to say, when the pointer goes up, what object do you want to call a function in or change or manipulate or play an animation on or whatever? We want to drag our arm controller in here, because that's the script that has this reset sliders function in it, and that's the function we want to call. So we've dragged it in, and there it is. It says no function. We do want to go down to the arm controller, and we want to find our function reset sliders. There it is. And that's all we do. So when the pointer is up on this slider, it will call that function, and that means that will zero everything out. It's really nifty way to do things. So let's just go and do that same exact thing we just did on pointer up. Let's create a new one. Let's drag arm controller over there. Let's go back to the arm controller here and call the reset sliders function. And finally, let's hit save. and then save project. Okay, let's hit play. Moment of truth. Let me check the ARM controller and make sure that we have a turn rate set. Yes. We have clamped. It can go negative 45 degrees around counterclockwise 45. Okay. Let's hit play and just try this. So I'm going to slide to the right. Yep. And it turned. I'm going to slide the other way and it turns the other way. And it stops moving and resets back to the center when I am done sliding. The snap reset function on pointer up is working. Okay, and then let's try this. Yep, look at that. Perfect. Let me undock this so we can kind of look at it in the scene view as well. Yeah, so one thing I'm seeing is for the arm rotation, we could probably go 60 and maybe 50, and let's try to rotate the arm. Let's see. Yeah, much farther down and much further up. And we could rotate the base. We could rotate the base 360 degrees around if we wanted. We can just go 80 and 80. Yep. Or 90 and 90 are kind of cool. That's fully functional. Okay, now that we've completed the C# scripting, we have this fully functional robotic arm that we can control through the user interface here. Some ideas on this is this code could be easily extended to include a reset button that will reset all the arm rotations back to a default state. You could extend this code to use a physical device such as a keyboard or gamepad for input instead of these sliders. And if you provide enough inputs, you could, in theory, create rotations and controls for many more pieces of the armature on this. We could have rotated this end piece. We could rotate this. We could turn these gears. You could rotate basically all of the pieces of armature on this. But I'm going to leave that up to the creative imaginations of all of you out there. And hopefully this has provided a small enough stepping stone, into a larger world of possibilities. So as always, I've appreciated all of you as viewers, and I'm open to any feedback or advice on subjects to cover. Don't forget that if you've enjoyed this content and would like to see more tutorials on how to do interesting things in Unity, make sure to tap the subscribe button below, and have a good day.